Welcome everybody. My name is Neil Ruane. I'm the Aquaculture Manager at the Marine Institute in Ireland. And thank you for attending this Precision Aquaculture in the Blue Economy webinar. This webinar is the third and final webinar in the Horizon4Aquaculture series, co-organized by three EU Horizon 2020 funded projects, IMPAQT, GAIN and iFishIENCi. The previous webinars have focused on policy and circularity, and in this webinar we will focus on the technological developments, innovation and monitoring within the three projects and their relevance to precision aquaculture through trials and pilot sites and end user experience. So it's going to be a busy session. We have a number of participants and presentations to get through, which will probably leave us a bit tight on time. We therefore invite you, the audience, to send us your questions using Zoom's Q&A tool, and we will endeavour to answer all questions either live or in writing afterwards. And we will provide you with the links where you can learn more about the work presented today. So to kick off, we will have a very brief overview of all three projects. And we will start with the IMPAQT project presented by Frank Kane, who's the project coordinator at the Marine Institute in Ireland.
Good morning. Thanks for joining the webinar on precision aquaculture. I'm Frank Kane, the coordinator of the IMPAQT project, and I'll give you a brief introduction to the project and the work carried out within it. The Horizon 2020 funded project is a collaboration of 21 multidisciplinary international partners from across the EU, including Turkey and China. You'll have heard from many of the partners over the last two webinars, and you'll hear from a number of them also today. The IMPAQT project is working to develop and demonstrate an intelligent technological platform for the sustainable management of an IMTA farm. The platform is to cover multiple production environments with the ambition to help validate the concept of IMTA as a viable aquaculture approach. The project is working on three key technological areas: an autonomous data acquisition and communication system, the IMPAQT platform, an advanced IMTA model, and the intelligent management system. These combine to form a management structure for a complete holistic system view. You'll hear details on many of these technologies and their application later. Here's a graphical overview of the IMPAQT system. And just to set the scene on the technologies you'll hear about later, this is an IMPAQT farm with the species grown together in a way that they complement each other, with the waste from the fish serving as a nutrient source and food for the lower trophic species. To monitor the stock and environment, a number of off-the-shelf sensors and novel sensors are placed around the site, measuring various different parameters. To collect the data locally from these parameters, the IADAS is placed at the pen, and this collects data from the multiple sensors and transmits it wirelessly to the DAS or data aggregator nearby. The data aggregator sends and stores this data in the cloud, and the power is managed by the novel energy management system. The local data is complemented with data from a variety of different sources: remote, crowdsourcing, lab, modeling data, all which feed into the intelligent management system. The IMS, or Intelligent Management System, analyzes, reports, and contextualizes the data for the operator through the dashboard. You will hear specifics on much of these in the upcoming talks. In IMPAQT, much of the work is focused on 6 pilot sites. They are SAMS in Scotland, the North Sea Farms in the Netherlands, Keywater Fisheries site in Sligo in Ireland, the Marine Institute Lehanapool Research Site, our industrial partners Chamley in Turkey, and IMTA experts in the Yellow Sea Fisheries Research Institute with their site in Sangao Bay. These pilot sites explored the potential for IMTA and were used to test and validate the IMPAQT platform, the model, and IMTA products and practices. And you'll hear from them in the user experience section. So that's a brief overview and sort of insight into what's coming up. Now I'll hand you over to Roberto Pastrez, the coordinator of the GAIN project.
Thank you very much, Frank, and thank you very much to all people who are listening to us today. I'm the coordinator of the GAIN project, which stands for Green Aquaculture Intensification in Europe. The main goal of GAIN is to foster the ecological intensification of European aquaculture. In order to achieve this overall objective, we get together 20 partners overall, 18 partners from the European Economic Area and 2 international partners from Canada and China, and 1 third party from US. In GAIN, we implemented different activities at 10 pilot sites covering different aquaculture typologies and species such as salmon, trout, bass, bream, carp, shrimp, mussel, and oyster. Next, please. How did we interpret the ecological intensification and how we try to promote this concept, which is in line, I would say, with the new buzzword ecological transition. So we combine together the improvement in husbandry practices through precision aquaculture in order to optimize, for example, feeding, oxygen supply, and therefore reduce both economic and environmental costs through the use of big data dynamic models and data-driven models. Of course, this will be presented in detail in this workshop, and at the core of this system there will be a platform that to some extent looks similar to the one that was design in IMPAQT. It will be very interesting to see the differences between our approaches. That was combined with activities in which we investigated the possibility of reusing mortality, secondary products, and wastewater in order to reduce the use of primary resources and extract as much product as possible from the aquaculture sector. So we investigated different possibilities to reuse these products. And in the end, of course, we wanted to show that all our innovation are more sustainable than, let's say, mainstream processes. So in GAIN, we have a work package dedicated to the sustainability assessment of our innovative processes. Before I finish, next please, since GAIN is going to be over in October, we are foreseeing more training and dissemination activities. As you can see here, there will be a summer school at the end of August and a training on novel aquafeeds, which is another area in which we provide some innovation, putting together emerging ingredients and ingredients from aquaculture byproducts. Of course, those of you who are interested in that can write to me or to addresses, or to the addresses on the slide. That's all, and thank you very much again. And I think that Frank can give the word to the next speaker.
Yeah, our final speaker in this session will be Dominique Durand, representing the iFishIENCi project.
Thank you, Frank, and good morning, everyone. So the iFishIENCi project is an innovation actions directed to intelligent fish feeding through integration of enabling technology and circular principle. It was funded by the Horizon 2020 under our Blue Growth and Digitizing call in 2018 on the Sustainable Aquaculture 4.0. Next slide, please, Frank. Thank you. So the project is are built on 2 pillars, a technology pillars, basically to develop control systems of feeding, and a feeding and feeds pillar related to sustainable new feeds and feed additive or feed ingredients, and looking at the sustainability of the system and the circularity in the system. The main innovations are related to a monitoring and control system, including digital twin, smart feeding technology, new fish feeds and feed additives, valorization of sludge and production water, and also a breeding activity looking at breeding for feed and feed methods. We have 4 main products that we are developing. The first one, the Fish Talk to Me, is really about putting online information and data in real time on the fish behavior, welfare, and health as the key for decision making and on the what to do according to how the fish are in their production environment. The Fish Talk to Me is included or integrated into the iBoss system, which is an intelligent biology online steering system dedicated to automatization of fish feeding. It's an IoT-based and enabling package with artificial intelligence-based decision-making system. The iBoss is to be integrated, demonstrated in different environments. I'll come back to that, but also integrating especially on the RAS, or Recirculating Aquaculture system, to develop the smart RAS and demonstrate the new capability coming from this control system in feeds, and demonstrating also the new feed capability. And the fourth product is looking at the new value chain for valorization, has a roadmap for fish aquaculture in the future. Next slide, please. So in the product, we're focusing on 4 marine and 3 freshwater species. You have the names here. So looking at different environments, looking at 5 production systems: open cages, semi-closed containment system, RAS, pound, and incentive flow-through systems. The entire project is aiming at progressing in terms of the innovation from a technological readiness level of 4 to a technology TRL 7, going through test sites and demo sites. So we have demo sites in Greece, in Malta, in Hungary, in Laos, in Germany, and in Norway, depending on the different species. Next slide, please. So the main impact, so even if the project was funded before the European Green Deal and the Farm to Fork strategy was launched, so the project is really contributing to the European strategy related to these 2 endeavors. Of course, so the main aspect is having a consumer acceptance and improving the consumer perception and acceptability of European aquaculture products and methods. The technology part on the Aquaculture 4.0, so the digitizing, so is in support to a greener industry and to a more sustainable production. Of course, we are looking also to the sustainable feed sources, also to accompany the revolution necessary in the aquafish industry to go from fish-based oil and soy to other type of ingredient, but also looking at some specific functional feeds ingredient. The greener production through improved feeding practices, and also looking at this circularity. All aspects are related also to in creating new value chain and new market, and therefore new jobs related to both the greener and the feeding and the fish farming in itself. Next slide. So you are going to, so the project is 16 partners, 2/3 being from the private sector and 1/3 more on the research and development sector. And you are going to hear later on today, this afternoon, especially some specific highlights of the project, both on the technology, on the Fish Talk to Me, on the RAS, and on the iBoss products. Thank you.
Okay, thank you to all our speakers. Sorry, I pressed the wrong button there. So now, thank you. We're all doing very well on time. And we now move on to our keynote presentation for today. And I would like to present to you our keynote speaker, Dr. Sara Barrento, from the Center for Sustainable Aquatic Research at Swansea University. Dr. Barrento is a marine biologist with experience in managing a number of international projects on sustainable fisheries and aquaculture, in addition to being an expert in scientific communication and education. She is currently involved in an Ireland-Wales Interreg Stream project, which is investigating sensor technologies for remote environmental aquatic monitoring. Sara, it's all yours.
Hi, thank you. I'm afraid I'm not able to share my video. I hope that's okay. It says that the host doesn't allow me to share my video. Can you see though? Can you see my presentation, although you can't see myself?
Yes, we can see your presentation.
Okay, brilliant. So I'll be basically doing a warm up about this webinar on precision aquaculture, and I'll try just to explain what precision aquaculture is. So I think always, I know everyone knows what aquaculture is, but I think it's also very important to remind ourselves that aquaculture is a very vast term that includes the farming of many different species, from fish, mollusks, crustaceans, aquatic plants. This includes from microalgae to seaweeds and even amphibians. And all these can happen in a marine environment, freshwater environment, and as we mentioned before, in the other projects, you have many different types of production systems. You can have a recirculating aquaculture system, a pond-based system at sea. You can have ropes, cage. It's a big and vast industry. When we talk about precision aquaculture, what we're adding to this is the fact that we now have the technology to have sensors that acquire data that will allow us to have a better decision support for different farm operations. These sensors can be about pH and salinity. These are the basic ones, the ones that we've been using for a long time now, but I would like also to introduce new ones and better technology for accessing other parameters. So thank you for allowing me to start my video. What I wanted to say is that precision in farming systems is not new, especially in agriculture is way ahead of aquaculture, basically because these are land-based systems, and the terrestrial animals and crops are easier to develop precision aquaculture. This is a graph that shows in the last 6 years a number of review articles, research articles, and book chapters. This is retrieved from Science Direct, and as you can see, they're in the literature. Just talking about the literature, we have 10 times more the literature about precision farming in agriculture than aquaculture. And we are used to seeing satellites and all these things in farming for crops and animals in land-based systems and terrestrial. So, but in aquaculture, we have precision, especially with recirculating aquaculture systems. I mean, for instance, where I work at the Center for Sustainable Aquatic Research, we have, of course, the typical recirculating system where we have all the sensors, the pH, the salinity, temperature, oxygen, and of course, we have alarm systems if these values go above or below the optimal parameters for the specific species. Of course, we have alarms, but also in more detailed recirculating systems, we have automatic feeders, and we have a feeding management, and all this data is collected to manage what I call the management of production and troubleshooting. So this is initially how we've been dealing with precision aquaculture, is to manage your biomass and is to troubleshoot, to make sure that everything goes as planned. And bear in mind, a recirculating aquaculture system is a live support system. So if we don't keep these parameters within the range for the specific species, there is nothing that the system will do for us. I mean, it's not like in a natural environment. It doesn't regulate itself. It is based on all this technology. So it needs to be totally automatized in a way, and the data needs to be there. So, but what we're seeing, and this is, a panel, typical panel for, salinity and all these environmental parameters. But what we're seeing now is that we're moving from precision aquaculture and we're moving at sea. Of course, moving to at sea facilities or production systems has many challenges for precision aquaculture beyond what is typical, for instance, in agriculture, because this is a harsh environment at sea. The access can be impeded by weather. The power and connectivity can be very challenging in these conditions offshore, usually, and we have large range of spatial scales. So, but it is actually precisely this, that is the fact that industry is moving with its farms and are getting bigger and moving offshore. This is precisely what is also pushing precision in aquaculture. And also the technology is getting better. We have new real-time sensor technologies that can support and can face some of these challenges that I've just mentioned. And then there is a third level, which is very important, that is also pushing this forward, which is a society. And the fact that there are pressures, especially from consumers, but also from regulators, of course, also responding to consumers about the need for sustainable farming, sustainable aquaculture, And especially if we consider fish farming, we need to have better and really good animal welfare. And now, on top of this, we are now talking about something different and beyond this, which is restorative aquaculture. And I think it's very important to see that precision aquaculture can have, and the sensors can have a big impact in developing and moving forward the restorative aquaculture. But I think at this moment, it's very important to explain what it is. So if in the past we are mostly preoccupied about preventing, minimizing negative impacts of aquaculture, like eutrophication, for instance, escape of species when we're talking about at-sea production systems. Now we're moving to the next level, which is actually having a new, different view of aquaculture, which is to provide positive environmental effects. So it's actually not only focusing on the negatives that we need to prevent, is actually thinking, what can we bring to the natural environment? And this is mostly talking about when we have open or semi-open systems at sea. What can it bring to the nature and support long-term sustainable use of the natural resources? And I think this is very important. I'll explain a bit later. So, but what does it look like? What is precision aquaculture and its framework? And then I mentioned in the beginning, it's all about collecting data. Everyone knows that in the 21st century, especially now, data is the raw material of 21st century. So we need to collect data. And if we go back to the recirculating aquaculture systems, you're very used to have the typical sensors that collect temperature, the pH, salinity, and oxygen. If we go to at-sea environments, we can have an extra level where we check the nutrients and potentially some pollutants. We can also have sensors and data being collected specifically to the species in question. So it can be a biomass. So how much is the biomass also growing? Is it growing? What's the mortality? But with cameras, we can also check the behavior. Are they feeding, for instance? Or I'll show an example of what can happen with the cleaner fish industry, specifically with the lumpfish, in a few minutes. And then we also have sensors that can check the physiology, lactate, for instance, cortisol levels. And then if we go back again to at-sea farms, it is very important to have weather forecasts and hydrography, also to manage the farm. Okay, is it going to be a storm in a couple of days or in a week time? What can we do to mitigate or to minimize the impacts of this storm? When you're talking, of course, at-sea farms. And then we have, we have all this data. We need to make some sense about this data. So we need to have models and we need to have insights. When I mean insight is basically what is the data telling you, what are the graphs, what are the image analysis, what they can tell you, and in this case can be about species growth and, as I mentioned, forecasts. And this, once we have this, we can support the decision for the farmer. It could be, if we're talking about a fed species, we could be feeding management, it can be a harvesting schedule, it can be a veterinary intervention, a early warning system. I mentioned the case of a storm, and also related to risk analysis. Data can also be very important, for instance, for insurance. So basically, in this framework, we have the sensors that allows us to observe and collect data. Then we have these models and insights that allows us to interpret this data. And then we have a decision and we can decide and act upon what this data is telling us. So basically, let me go to the next slide. Oops, sorry. So basically, when we talk about precision aquaculture now at sea, and I call this a traditional view, of course, this is new still, but it's mainly, until now, it's been mainly focusing on troubleshooting and management. So basically, and if you go back to papers and diagrams, you usually see a fish in a cage, and then you have a variety of sensors. You can have cameras, you can have acoustic telemetry, and all this now we can have all this with live monitoring data, real data being collected live every single minute or every single hour. But actually, this doesn't really just focus. The focus can not only be on managing and troubleshooting of, for instance, fish species. We can and we should have this expanding to other concepts. Let me just show you. I'd like to precisely on this way of expanding this, not only to the troubleshooting. I would just like to give you the example of this This farm in Pembrokeshire in Wales that we are collaborating with, it's the Karamor. It means for the love of the sea. Karamor is the Welsh word. And basically what they're trying to do is a community-based society where they're going to grow kelps. The sugar kelp is one of them. They're going to grow scallops, they're already doing this, and oysters, and the plan is to do mussels. So the typical, in this case, IMTA without the fish component. So in this case, and one of the things that it's been quite difficult is the licensing. So in this type of new ventures, I specifically think that precision aquaculture can be a great help because it can access new site locations, for instance. And then by actually monitoring and doing a survey to the habitat where we think that this new aquaculture could be set up. And then this also can support the licensing process by having all this data and giving a clear image of what we are planning to do and what are the impacts, the positive and negatives. And then, of course, then once we have the farm, we can use precision aquaculture for management and troubleshooting. And then we can actually think about certification. And going forward, I think it's very important at this moment where we talk so much about ecosystem services and restorative farming, we need to validate. We need to have data to actually say and state with clarity and real data, look, this is what is happening and this has a positive impact if done in this such way, if the management is well done. So, and having said this, and trying to include this precision aquaculture into the whole process from trying to find a site all the way to consumer, let's say, because of the certification, we need to think about aquaculture as having impact, positive or negative, in this case, impact and benefits. And precision aquaculture can help in accessing the environmental conditions, which allow us in the beginning to establish what are the best species to be cultivated in this site, what is the scale, what is intensity, because based on intensity and scale, we can then see, we can actually push forward a positive impact. And of course, the cultivation gear, what is it that we're going to use? Some types of farming, some types of cultivation gear can actually potentially, depending on the site location, promote biodiversity, for instance. And then we can also need to take in consideration farm management. So, and all this is interconnected because it can have a positive or a negative impact depending on how we deal with all these aspects. And I believe that precision aquaculture and having the ability to collect this data at different stages for different purposes can have a more holistic view of aquaculture in itself. So now this is Karamor. They had difficulties in trying to get the licensing. They now want to expand and they want to find new sites. And this is where the precision comes. And then there is a company that is also collaborating, which is Pebble. Plant ecology beyond land. What they're trying to do is just getting a cheap way to get the core data that you need just to, in this case, for this specific type of farm where you have shellfish and seaweeds. So they just collect from whatever you got from off the shelf, sensors that will sense and collect data on pH, salinity, light, in this case important because we have seaweeds, the flow, the temperature, and they have a camera. So the concept is, and the idea is to make it as cheap as possible, around £1,000. They also have a very clever way to check the current sensor, which is based on the tilt current sensor in the seabed. And this is how it looks. And their aim is actually to have a cheap, affordable way of getting this data. And actually, I think avoiding Yagi, which is you're not going to use it. Sometimes we over-engineer things and we try to get as much data as possible. And sometimes you don't need as much or as frequent. So, and those things actually cost a lot of money. So let's keep it to the basics. And I really like this concept. So another company that we're working with is Faptic, and what they're doing, they're employing machine vision to detect lumpfish. Thank you, Neil. I saw I have 1 minute. I'll keep to the schedule. So in this case, lumpfish are cleaner fish. They can cling or swim, and they are using artificial intelligence not only to check how many fish have we got there, what is the density, but also where are they within the tank, and are they clinging, are they swimming? This is important for welfare purposes. So we've seen precision aquaculture from recirculating aquaculture systems to at sea. The next level is wearable sensors. Just like we wear sensors to measure our heart rate, we can now have the extra level of having sensors that are within the fish, wearing by the fish, that will be collecting biomarkers, okay? So the real-time analysis of biomarkers, as I mentioned here, using wearable sensors technology offers non-invasive data collection. So to conclude, so moving forward, we need to have robust and low-cost sensors capable of underwater and in-air wireless connectivity, high level of interoperability. And then we have data management, which is crucial. I don't think we'll have time here, but security sovereignty is important to discuss at some point for ethical reasons, because this is about commercial sustainability and data. And above all, what I think we should have with sensors is, avoid the you're not going to need it type of over-engineered type of sensors. So I would just want to thank my colleagues from Pebble, from FAPTIC, from Karamor, and the projects that are funding this, which is the Access to Sea, Stream, and Smart Aqua. Thank you.
Thank you very much, Sara. That was really interesting and perfectly on time. So we're just going to take a short 5-minute comfort break. Before we do that, I would just like to remind people, if they have any questions, and thank you to those who've already submitted, you can post your questions on the Q&A and we will get to them during the webinar. So we will reconvene at 35 minutes past the hour. Thank you very much.